Section 3.2 is on ionic compounds. Now, ionic compounds are formed as a way for atoms to fill their octets. Here's what happens. Here's kind of our go-to example. This is very common, very familiar ionic compound to you. Sodium chloride. Which of course is table salt, has the formula of NaCl. Right? So let's look at this. I'm just going to draw these again. Let's look at our sodium atom. All right, there's 2 electrons in our N equals 1 shell. There's 2, 3, 4, 5, 6, 7, 8 in our N equals 2, and then there is 1 in our N equals 3. All right, then let's say that we have a chlorine here. And there's our nucleus, there's our N equals 1 shell with its 2 electrons in it, equals 2 with 2, 3, 4, 5, 6, 7, 8, and then N equals 3 with 1, 2, 3, 4, 5, 6, 7, which gives us the 17 total electrons, 7 valence electrons that chlorine should have. All right, so here as I've drawn them, we have these two sitting next to each other. They each want a full octet. Easiest way for sodium to get to a full octet is to give up 1 electron. Easiest way for chlorine to get to a full octet is to take 1 electron. So what happens? Chlorine takes this electron from sodium. Now they both have a full octet. We get an Na plus and we get a Cl minus. Yeah, okay, we have an Na plus and a Cl minus. What do opposites attract? They're oppositely charged, so they're going to stick together, give us an overall neutral compound, and give us the formula of NaCl. Okay? That's how ionic compounds are formed. Now, in the real world, when we form ionic compounds, oftentimes we aren't actually doing that exchange kind of in real time. Typically, we're working with ions that already exist. And in fact, this reaction is quite violent if we were to do this. But this is the basic idea behind how this works. All right, now let's look at a different example though. Let's say that we have magnesium and we have chlorine. All right, so if you remember, magnesium has 2 valence electrons. And of course, chlorine has 1. Okay, so first of all, magnesium wants to get rid of 2, but chlorine can only take 1. So what if we have a second chlorine down here, right? Now magnesium has a place to give up each of its valence electrons. So we have 1 magnesium, 2 chlorides. They come together and they give us the formula MgCl2. By the way, let me make a point of this. When we put these together to make an overall neutral compound, the charge goes away. I'll have people write this and want to stick a minus sign up here. No, that's not correct. MgCl2 is the name of this compound. Okay, let's look at just another example, and then I'm going to show you a shortcut to get to these formulas. Let's say that we have aluminum 3+, and we have oxygen, which forms a 2- ion, right? How are we going to stick these together to get an overall neutral compound, right? Well, aluminum's 3+, oxygen's 2-. So what if we have 2 oxygens, right? Well, that gives us a -4 charge total, which is still bigger than our aluminum 3+, or which is bigger now than our aluminum 3+. So let's stick a second aluminum there. That gives us 6+ total, but this is still only 4-. So let's put another oxygen down here to make oxygen 2-. Look at that. 2 aluminums go together in a ratio with oxygens, and we get the formula Al2O3. All right. Now, this can be a lot of work to sit here and figure all of this out, and it turns out there's a shortcut to getting to this formula, right? So we know we have Al3+, we know we have O2-. What we can do is we can just take this 3 here. So we take the absolute value of this, we bring it down here. We take this 2, bring it down here, and that gives us Al2O3. Again, charges go away. We're trying to form a compound with an overall neutral charge that cancels out completely. Right. So that's how that works. All right, let's talk though about how we name this, or about how we name ionic compounds in general. So ionic compounds follow the general rule of, to name them, we name the cation, and then we name the anion. All right? So magnesium chloride, okay? Now, they can only come together in this MgCl2 formula. By the way, we will make this compound in lab and determine its formula, but they can only come together in this ratio. So we just have to call this magnesium chloride. This one is aluminum oxide. Now, if we throw a transition metal in here, so let's say, just for example, you have the compound Fe2O3. All right. We know, looking at this from the periodic table, that oxygen has a -2 charge. But remember, we talked about how in section 3.2 how iron could be either +2 or +3. Which is it? Well, turns out that in this situation, it's +3. Feel free to convince yourself that that works out to give that formula. So the iron is a +3 charge. How do we indicate in the name of the compound that this is an iron +3? Here's what we do. We say iron 3, Roman numeral 3, oxide. Our last thing in this. If we have a polyatomic ion, we just name the polyatomic ion. So let's say, and actually I should mention this in the context of writing formulas also. Let's say that we have a compound between the ammonium ion and the sulfate ion. All right. To balance this out, we need 2 of these ammonium ions. We can't really do anything with this. It has to stay as ammonium. So we're just going to put that in parentheses, put a 2 down here. And then SO4, right? That's going to cancel out. And this is ammonium sulfate, right? That's ionic compounds in a nutshell.